Got another set of questions for the alkanes and haloalkanes topic. And as always, the link to the questions in the description of the video if you want to try them first. Okay, so we'll make a start with the multiple choice questions. So which alkane is 82.8% carbon by mass? So basically we've got to work out the mass of carbon and divide by the MR multiplied by 100. So there's all those calculations and you can see that C is the answer. Next question, which structural isomer of C7H16 has the weakest induced dipole-dipole interactions or London forces? Well, it's going to be the one with the most amount of branching. So you can see this has got 2 branches, this has got 1, this has got 2, this has got 3. So it's going to be D. Next one, 2-methylbutane, which there's the skeletal formula for it there, is reacted with chlorine by radical substitution. How many structural isomers with that molecular formula could you make? So it's obviously mono substitutions taking place. 1 hydrogen's come off, 1 chlorine's gone on. So the chlorine could go on these 2 carbons and they would be equivalent. The chlorine could go on here, so there's another one. It could go on here or it could go on here. So the answer was 4, so C. Moving on to the main questions now. So we've got to draw the structure of a halothane molecule, and we know the name is 2-bromo, 2-chloro, 1,1,1-trifluoroethane. So we've got 2 carbons. So we've obviously got 3 fluorines on 1 carbon. So we'll make this carbon 1. We've also got a bromine on the other carbon and a chlorine. So that must be a hydrogen. So that's the structure there. What's the number of fluorine atoms in that many grams of halothane? So we need to work out how many moles we've got first of all. So mass over MR, the MR was given up there, remember, 0.04 moles of halothane. Now, if you look at the formula, you've got 3 fluorine atoms in there. So the moles of fluorine atoms is going to be 3 times this. Now we've got the moles of fluorine atoms, we can multiply by Avogadro's number to get the number of them. So that's coming out at 7.224 times 10 to the 22. So moving on to the last part of this question. So we've got to come up with the equations of how Freon 13, this thing here, can lead to ozone depletion. So when this goes up into the upper atmosphere, it's exposed to UV. So the UV breaks the CCl bond, generates a chlorine radical, and the other part of this would also be a radical. So that's CF3 dot for the unpaired electron. So then the chlorine radical will attack the ozone via a pair of propagation steps. So the chlorine radical takes an oxygen, and it becomes a ClO radical and leaves an O2 molecule. Then the second propagation step involves the reaction of this radical with an oxygen atom. So there's the equation for that there. Now, it wasn't required for the question, but I'm just going to show you the overall equation for those 2 propagation steps. So we get this equation here, O3 plus O gives 2O2. So you can see that the O3, the ozone is being broken down, being depleted. Moving on to the next question. So a radical is a species with an unpaired electron. Part B, the type of bond breaking that occurs in the radical substitution reaction is homolytic fission. Part C, so when alkane A reacts with bromine and mono-substitution occurs, the 2 possible places for the bromine to go would be here or on one of these carbons here. So there's the 2 structures there. And for the final part of the question, this is not the final answer yet, it's not balanced, I just want to explain something first. So there's alkane A, we've got bromine, and we're told we've got to make 1,3-dibromo 2-methylpropane. So carbon 1, 2, 3. So 1,3-dibromo 2-methylpropane. The thing to remember with these reactions is every substitution requires a mole of halogen and every substitution makes a mole of hydrogen halide. So because we've got di substitution taking place, we need 2 moles of halogen and we make 2 moles of hydrogen bromide.